Welcome to topic number 28 in Richard James Mathematics Resources, and this one is entitled Sketching Parabolas. Sketching a curve can prove to be very useful. For one, it gives an idea of what the actual curve looks like without having to go through the problem of actually drawing the curve. Sometimes the important points that are to be included in the sketch can prove to be more important than the sketch itself. For example, there's a parabolic relationship between Mr. Brown's profit and the number of items that he produces in his factory. The minimum profit arrived at from the expression is $200,000 each month. We will have to do an investigation if his profit for a given month is $50,000. Nothing can be smaller than the minimum, so the investigation will definitely have to take place. Sketching parabolas is an introductory subtopic to sketching all kinds of curves. At this stage, some of the important points in the sketches of curves will be considered. A sketch of a curve is vital to the understanding of how a system should behave. Some special features are extreme points and the values of one variable when the other is equal to 0. Sometimes they are the only points of interest. Do not forget that many natural and man-made systems can be defined by algebraic expressions. A sketch can help in the analysis of the system, and it can be used in making predictions. In the case of man-made systems, they can be adjusted to give desired results, or new systems may be designed. The first point that we will consider is the point where the curve crosses the y or f of x axis. This point is always a feature of every parabola and is easily determined. So we have f of x is equal to x squared plus bx plus c, and that is our general representation of the parabola. The constant value is the point where the curve crosses the y or f of x axis. And that is our constant value. At the point where the curve crosses the y-axis, the value of x is 0. So if we substitute 0 in the place of x in the expression, what do we have? This term is going to be equal to 0, and this one also. The value of f of x will therefore be equal to c only. If the x ordinate is equal to 0, and the y or f of x ordinate equal to c, the point in question has coordinates 0, c. And that is where the curve crosses the y or f of x axis. The second point of interest is also a feature of every parabola. It is the extreme point. Use the completed square to assist in finding the coordinates of the extreme point. The constant expression gives the extreme value of y or f of x, and that we saw in the previous subtopic, in which we completed the square and the general representation of the quadratic expression. And of course, the constant value is the extreme value. So f of x is equal to 4ac minus b squared over 4a, and that is our constant value that will give the extreme value of f of x. For the x value at which the extremum occurs, the content of the bracket is equal to 0. So x plus b over 2a is equal to 0. Therefore, x is equal to negative b over 2a. So the coordinates of the extreme value will be negative b over 2a for the x and for the y, 4ac minus b squared over 4a. Those expressions will form the coordinates of the extreme point. Remember also that the x value gives the equation of the axis of symmetry. When the points of this feature occurs, they do so in pairs, but they do not always occur. And this is the third thing to consider. These are the x-intercepts and occur when y is equal to 0. We will get them by solving f of x is equal to 0. And of course, if we solve f of x is equal to 0 for this general expression, then we have the general solution of a quadratic expression that is given in the form of the quadratic formula. The general solution given is the quadratic formula, and the two solutions represent the two x ordinates. So, with the y ordinate equal to 0, in each case, the coordinates of the 2 points may be shown to be, that's one, and that is the other. So these are the 2 points where the curve crosses the x-axis. So the x ordinate of 1 will be minus b minus the square root of b squared minus 4ac over 2a, and the y ordinate will be 0. And the other one, exactly the same thing with the exception of the positive sign here. And of course the y ordinate is 0. The cumbersome expressions are placed in the diagram not because it is expected that we will use them to find the coordinates. As a matter of fact, we will not use them all the time, or sometimes we might not use them at all. We use them because they present general expressions that may be used to accompany the points of the sketch. So in this general representation of the sketch, those cumbersome expressions are used because they are the only general representations that we have available. Of course, they may be used to derive or to find the values of all of the ordinates of the points of interest, but we will not use those cumbersome formulae. The final consideration is whether the curve is U-shaped or umbrella-shaped. For this, let us adopt one slide from the topic maximum and minimum of quadratic expressions. So, quadratic expressions that have positive x squared coefficients results in curves that are U-shaped. The extreme point is at its lower end and is therefore a minimum. So we have the U-shaped curve. We have the U-shaped curve with the extreme value a minimum, and that is when the x squared coefficient is positive. For the other one, we have the negative x squared coefficient, and that will give a maximum value for the extreme value. So let us sketch the curve with the following equation. We're going to sketch that curve, and we are going to take a look at all the points of interest. The y-intercept is a constant value, and the corresponding x value is always 0. So the y-intercept, or the point where the curve crosses the y-axis, at that point x is equal to 0, and the point has coordinates 0, negative 8. So x is equal to 0, and the value of y will be that constant value of negative 8. The equation of the axis of symmetry will give the x value of the extreme point. So we are going to use the axis of symmetry this time instead of the completed square. So of course we have what? Our template, in which we should have negative b over 2a. What is the value of b in this case? Negative 2. What is the value of a? No coefficient there. So the value of a is considered to be 1. So x is equal to 1. And that will be substituted in the original expression in order that we may find the extreme value. So y is equal to 1 squared minus 2 times 1 minus 8. And simplifying, we get y is equal to negative 9. The coordinates of the extreme point will therefore be 1, negative 9. Now we need to determine the x-intercepts. So for the x-intercept, we cause y to be equal to 0. So if y is equal to 0, it means that x squared minus 2x minus 8 is equal to 0, and we are going to solve that. But of course, our prerequisite for this particular point, or this particular section of this presentation, is solution of quadratic equations, and we are going to be using the method of factorization. What two numbers multiply to give a negative 8 and will add to give a negative 2. So those two numbers are negative 4 and positive 2, and they will be accompanying x in the two factors, as we would have done in the topic factorization of trinomials. And of course, we have x is equal to 4 and x is equal to negative 2. That we'll get when we transpose this one. Negative 4 will be transposed to a positive 4, and a positive 2 will be transposed to a negative 2. And of course, all of this is explained in detail in volume 1 algebra. The factorization is topic number 4, and solution of quadratic equations will be topic number 7. With the y-ordinates of the 2 points equal to 0, the coordinates of the x-intercepts are 4, 0 and negative 2, 0. And of course, those are going to be placed on a sketch in order that we can sketch the curve. But the coefficient of x squared is positive. The curve will be U-shaped, and the extreme point will be a minimum. So recall the points of interest. We have 4 of them in this particular case. And in the diagram that will be used, the axes and the numberings will also be sketches. It will cater for the points that are to be included in the sketch, and the numbering will demonstrate this. So in this sketch, we have to cater for a y value of negative 8, a y value of negative 9, x values of 4 and negative 2. So let us show that. Of course, we have the 4 here, and we go all the way down to negative 3, although the point will be at x is equal to negative 2. And we have our y-ordinates represented here, one for the extreme value and one for the y-intercept. So draw the axis of symmetry to cross the x-axis at the x value of the extreme point, right there. So remember that the extreme point is 1, negative 9, and the x value will represent the axis of symmetry. Plot the points of interest. So we are going to plot the points of interest, and we are going to begin with the y-intercept. So let us begin with the y-intercept of 0, negative 8, crossing the y-axis at negative 8. Next, we have the extreme point. The coordinates of the extreme point will be 1, negative 9. So x is 1, y is negative 9. The point is placed right there. We have 2 x-intercepts. Usually for a parabola, when the x-intercepts occur, they occur in pair. So those x-intercepts will complete the quartet of points that we are going to be using in our sketch. The x squared coefficient is positive, so the curve will be U-shaped and the extreme point will be a minimum. The sketch will be completed by drawing a U-shaped curve that passes through the 4 points of interest. Curve has to pass through this point, this one, and that one, and it has to be U-shaped. Of course, it is going to be impossible to draw an umbrella-shaped curve that will pass through all of these points. So we have another curve to sketch. 2x squared plus 12x plus 19. The y-intercept is a constant value. The corresponding x value is x equals 0. That constant value will be the y-intercept. Therefore, the coordinates of the point will be 0, 19. The equation of the axis of symmetry will give the x value of the extreme point. So let us put in our template, and of course we mean minus b over 2a, and this is the value of b. A positive 12 will go there, and a is 2, so 2 times 2, we'll have that right there, and so x is equal to a negative 3 when we simplify this. Negative 12 divided by 4 is negative 3. Substitute this result in the original expression and find the value of y. So we are going to put negative 3 there. So we have 2 times negative 3 squared, or 2 times the square of negative 3. So that is 2 times the square of negative 3, and plus 12 times negative 3 plus 19, and see what we get. Square negative 3, 9, then multiply that by 2, we get 18. No problem seeing our negative 36 here, and our constant value is placed right there also. When we simplify that, we get y is equal to 1. The coordinates of the extreme point is therefore negative 3, 1. An attempt to solve the quadratic equation that results from equating y to 0 will show that there will not be any x-intercept. The expression cannot be factorized, and if the quadratic formula is used, the expression under the square root sign will be negative. Because the square root of a negative number does not exist, that means we will not have any x-intercept. The x-intercept will not exist. No solution for that quadratic equation, therefore no x-intercept. So if we check that portion under the square root sign, we will get 12 squared minus 4 times 2 times 19, that is 144 minus 152, and that is going to turn out to be negative. The result is negative 8. The square root of a negative number does not exist. Therefore, the equation has no solution. Therefore, there will be no x-intercept. So we are going to recall the points of interest. This time we have only 2 of them. Use makeshift axes and labels as in a sketch. Make sure to include the values on each axis that will act as ordinates for the points of interest. Therefore, the axis must accommodate 19 on the y-axis, negative 3 on the x-axis, and 1 on the y-axis. So there we have 19 on the y and 1 on the y, negative 3. So the curve may be sketched with the point of interest shown on the diagram. So draw the axis of symmetry to cross the x-axis at the value of the extreme point. So the equation of the axis of symmetry would have been x is equal to negative 3. So the axis of symmetry will pass through that point. Draw a horizontal line at the y value of the extreme point. It is not a necessity, but it acts as a guide that demonstrates the level at which the extreme point should be placed. The y-intercept goes first. So let us put that y-intercept first. The only other point of interest is the extreme point, and that extreme point goes right there. So the x squared coefficient is positive, so the curve will be u-shaped and the extreme point will be a minimum. There is no other point of interest. However, a u-shaped curve that is symmetrical about the line x is equal to -3 should suffice. The extreme point is right there, the minimum, and the curve is required to be symmetrical about this point and also passing through y is equal to 19. Let us sketch the curve with the following equation: x squared minus 4x plus 4. A very interesting curve indeed. The y-intercept is a constant value and the corresponding x value is x is equal to 0. So the point, which is the y-intercept, will have coordinates 0, 4. The equation of the axis of symmetry will give the x value of the extreme point. So we know that minus b over 2a. X is equal to 2. Substitute this result in the original expression and find the value of y. So let us put 2 into this and see what y is equal to. So we have the simplified version of that, and we have y is equal to 0. The coordinates of the extreme point is therefore 2, 0. Equate y to 0 in order to find the x-intercept. Now, what do we realize here? We realize that the coordinates of the extreme point is 2, 0. So we're going to equate y to 0 in order to find the x-intercept. What are the x-intercepts? Solve the quadratic equation to find the values of x. We have x minus 2, x minus 2. So here we have x is equal to 2 in both cases. The coordinates of the x-intercepts are 2, 0 and 2, 0. A quadratic equation must have two solutions called roots. When they are the same, we say that the equation has equal roots. It is noteworthy that the x-intercepts and the extreme point have the same coordinates. Notice that we have the x-intercepts here and we have the extreme point here. They are the same point. So all of those points will coincide with each other. The coefficient of x squared is positive. The curve will be u-shaped and the extreme point will be a minimum. Recall the points of interest. There are only two of them because the two x-intercepts turn out to be 2, 0 and the extreme point also turns out to be 2, 0. So use makeshift axes as usual and make sure that we can cater for y is equal to 4 and x is equal to 2. So there we have them. Remember now, draw the axis of symmetry to cross the x-axis at the value of the extreme point. So the x value of the extreme point. So the axis of symmetry goes there. So the extreme point is going to be here, which is the minimum value. So the curve will come down and go to a minimum right here, and will go away like that again. And do not forget that the x-intercepts will be right here also. So let us draw that curve, or let us plot the points of interest. So the first one is 0, 4, and that is the y-intercept. The only other point of interest is the extreme point, which is 2, 0, and of course the extreme point will prove to be the x-intercept also. The x-squared coefficient is positive, so the curve will be u-shaped and the extreme point will be a minimum. There is no other point of interest. However, a u-shaped curve that is symmetrical about x is equal to 2 should suffice. So coming up is the first curve of the other type of parabola. That is the one where the x-squared coefficient is negative. The y-intercept is a constant value and the corresponding x value is 0. The point has coordinates 0, -15. The equation of the axis of symmetry will give the x value of the extreme point, and of course we have minus b over 2a. b is 8, will go there, and a is a -1, will go there, and simplifying that we get x is equal to 4, and that will be substituted in the original expression in order to find the extreme value. So we have y is equal to -4 all squared, because that's the value of x, plus 4 times 8, or 8 times 4, minus 15. So when we put that neatly together, we get y is equal to 1. And that is going to be the extreme value of the expression. The coordinates of the extreme point is therefore 4, 1. Equate y to 0 in order to find the x-intercepts. Now what we have here is an equation with a negative x-squared coefficient. When we are writing the equation, we may rewrite this as x squared minus 8x plus 15. Solve the quadratic equation to find the value of x. Now here we have the expression already factorized. And of course, the reason for being so short-handed is because we have done an enormous amount of work on solution of quadratic equations. Now if we change all of these signs, we will have x squared minus 8x plus 15 is equal to 0. And we need to find the two numbers that multiply to give a positive 15 and add to give a negative 8. And those will be -3 and -5. When we solve our equation, we get x is equal to 3 and x is equal to 5, and those will be the ordinates, the x ordinates of the points, the y ordinates being equal to 0. The two x-intercepts are 3, 0 and 5, 0. The coefficient of x squared is negative. The curve will be an umbrella-shaped curve, and the extreme point will be a maximum. So there we have the points of interest, and of course we are going to make our makeshift diagram, which is a sketch that will cater for y is -15, and of course these x values of 3 and 5, and positive y value of 1. So let us see what we make of it. All of the values are represented there. Draw the axis of symmetry to cross the x-axis at the x value of the extreme point, and the extreme point is 4, 1, so the x value is 4. The axis of symmetry will be right there, and at the same time we are including a marker to show the level of the extreme point, which is at y is equal to 1. Plot the points of interest. The first one is 0, -15, which is the y-intercept. It goes right there. Then, of course, we're going to have the extreme point, which is 4, 1, right there. Then, we'll have the x-intercepts, 3 and 5. And of course, because the coefficient of x squared is negative, the curve will be umbrella shaped and the extreme point will be a maximum. The sketch will be completed by drawing an umbrella shaped curve that passes through the 4 points of interest. Right there. Now, in this section, the equations of 4 curves will be given along with their sketches and discussions. So we'll see why the sketch is given like that: negative x squared plus 2x minus 3. So to the left is a sketch of the curve. The expression cannot be factorized and the quadratic formula does not generate real values. Therefore, there is no x-intercept, no point where the curve will cross the x-axis. The value of x squared is negative. Therefore, we will have an umbrella-shaped curve and a maximum extreme value. If the maximum is a negative, that means the curve is going to be below, all of the curve is going to be below the x-axis, and that also will indicate that we will not have any x-intercept. So the extreme value, we use the axis of symmetry minus b over 2a, and we get the x value. Usually we substitute that x value into the equation or the expression, the general expression that we have right here, and we simplify and we get the y value of the extreme point, which is negative 2. So the y value is negative 2 and the x value is 1. So we have negative 2, 1. The y-intercept is the constant value, and that is negative 3, so the curve will cross here also. No other point of interest. Those are the 2 points that we are going to use to sketch that curve. Next we have an interesting curve. The equation does not have a constant value. This is because the value of the constant is 0. The y-intercept is therefore equal to 0. If the right hand side is equated to 0, the two solutions will be equal to 0. Therefore, what we have is that the constant value is equal to 0, so the y-intercept is equal to 0. And if we are going to solve f of x equal to 0, in order to determine the values of the x-intercept, we will get x squared equal to 0. So the x-intercepts will both be equal to 0. What about the axis of symmetry? Minus b over 2a. The value of b is also equal to 0. Therefore, the axis of symmetry will be x is equal to 0. And which line has that equation? The line that has the equation x is equal to 0 is the y-axis. So the axis of symmetry in this case will be the y-axis. The x-intercepts will be equal to 0 and the y-intercept is equal to 0. So that is why we have our curve drawn like that. Symmetrical about the y-axis, and the x and y-intercepts are at the origin. So extreme value, let us see what we do for the extreme value. The x value will turn out to be 0. And when we put that in the original equation, the y value is equal to 0. So the extreme value will be at the origin with x is equal to 0 and y is equal to 0. The x-intercept, we say f of x is equal to 0. So negative x squared is equal to 0. And of course, x squared is equal to 0 will give 0 and 0 also. So the x-intercepts will also be right there. The y-intercept is the constant value. There is none in this expression. So the value of the constant is equal to 0. Here we have another curve. The constant value is -9, and this will be our y-intercept. So we expect the y-intercept to be at -9. The expression is a difference of two squares, and when the equation is formed, the two solutions will be the two square roots of 9, which is one will be a +3 and the other will be a -3. Therefore, the x-intercepts will be +3 and -3. They will be the x-intercepts. As in the previous situation, b is equal to 0. The axis of symmetry will have equation x is equal to 0, which of course is the equation of the y-axis. The y-axis will therefore be the axis of symmetry. The extreme value, we put the value of b there, and what do we notice? X is equal to 0, and that equation of the y-axis, and y is equal to 0 squared minus 9, so y is equal to -9. So the extreme point will be 0, -9. What about the x-intercepts? X squared minus 9 is equal to 0, so factorize the difference of two squares, and the answers will be x is equal to plus or minus 3. The y-intercept is the constant value, and the constant value is -9. Finally, we have this curve, x squared minus 4x. There is no constant, so the value of the constant is assumed to be 0. The y-intercept is therefore 0, and the curve will pass through the origin. Because of this, we will expect one of the x-intercept to be at the origin also. Therefore, if the y-intercept is 0, because there is no constant value, so the y-intercept is the point 0, 0, indicating that when y is equal to 0, x is equal to 0. Therefore, if x is equal to 0, y is also equal to 0. So that point will also be one of the x-intercepts. If y is equated to 0, the equation will give two solutions, one with x equals 0 as expected, and the other at x is equal to 4. So extreme value, look at the extreme value, we have -4 right there, and 2 times 1, see what we have? The value of x is equal to 2, and that will be the equation of the axis of symmetry. Substituting that into the expression, this is our result, and y is equal to -4. So it passes through 2, -4. So the extreme value is -4, and the corresponding x value is 2. So the intercepts equate this to 0, and we factorize, we have x to be multiplied by x minus 4, that is equal to 0, and we solve that equation, x is equal to 0 or 4. So the y-intercept is the constant value. There is none in this expression, so the value of the constant is equal to 0, and the y-intercept will be right there. The most important points to note when sketching curves in general are also some of the most important points to note when sketching a parabola. Some other curves will have no x-intercept, and the number of maxima and minima may be greater. Since the maxima and minima are not usually extreme points, when the curve has more than one, they are called relative maxima and minima. Any further work in sketching curves will definitely be an extension of the concepts that we have just covered. Therefore, all scholars will do well to ensure that the concepts are understood, and it is advisable that students practice by sketching as many curves as possible.